Hello, I'm Stephen from the Hong Kong Jockey Club. Today, I would like to share with you what it is like for a developer to design applications for enterprise event-driven architecture. The aim of this architecture role style is to enable agility by providing a framework and standards within which the development community can work. There is no indication that data is enabling factor to make this style work, and a canonical data model reduces data transformation to an absolute minimum, increases speed and reduces errors. Using this model will also decouple servers and allow data distribution to multiple endpoints. Another advantage this style is to reuse of existing components. The first question, what is the event? When we're talking about the EDA, what is the event? Any real-time activity that happens is an event. It can be triggered by user actions, system, or other events from upstream in the data flow. Any downstream services would need to handle these events in real time. Event can also be triggered by physical object or things. At the Jockey Club, for example, the physical device the starter used at the draw could be consumed by multiple events. Open the gates, close the rating pools, commence the racing timer, sounds the starting bell, and any other services related to the drum. Therefore, an event is triggered whenever there is a change, be it physical or a code. We have more than 100 systems in our network. Most of the legacy systems were built based on point-to-point integration and are tightly coupled with each other. This means that we need to cater to different communication protocol and maintain different information styles while thousands of interfaces. Even if we only want to change one data field in the backend, it could affect up to 30 other systems. More interfaces and more services also means higher cost, higher risk, and longer implementation time. Additionally, we need to address network and security compliance issues, as well as maintain a complicated monitoring solution. Extra logic must also be added to the application to trigger alert or for other purposes. All of this additional change will affect the performance. So we end up spending a lot of time discussing the impact of a change with many different teams. On the SAT testing periods, we also need to test everything from end to end. And just to be on the safe side, we also need to test the parts that may not be affected. A minor change could take up a year to implement. This design is not flexible enough to address the user requirement of time to market and lower cost. EDA is an ideal architecture and it can be implemented with different technologies. End users always want to big change on a very tight budget and launch quickly with very low risk. Was it possible to achieve this using the traditional design as described previously? No, it is impossible. Today, we have built up a well-defined event mesh infrastructure to link the different network segments together and provide a self-service platform to our application. We are converting traditional systems to microservices and enforcing EDA design on the whole design. We also use auto deployment and test tools to improve product quality and reduce risk. Compared with the traditional design, EDA can provide lots of the benefit to us, minimizing support interface by a service does not just decrease complexity, but also reduce cost. For an enterprise with 166 services, the maximum number of the interfaces is 13,695. The total cost of ownership is then calculated from the number of the interfaces multiplied by the cost of management and interface. Reducing the interfaces to a single interface per service reduce the number of interfaces by 13,529, resulting in a significant cost saving. Less interfaces to maintain also means faster time to the market. Availability, scalability, and reliability are used to measure the success of a solution. An application based on our design provides a better return on investment by helping applications become available, scalable, and reliable. A change in requirement is painful. When following a traditional PTLC waterfall model, as this could mean restarting the cycle again, but with EDA concepts and Agile processes, the development cycle is split into smaller sprints to allow for more flexibility and thus better accommodate required changes. We now follow a 5-step process and implement changes: discover, design, develop, test, and deploy. This process can be repeated bi-weekly or daily. Let us have a look at how can we add an extra view on the UI within one day. The first phase is discover. We start with the understanding of the user requirement. We do this by identifying business use case and discussing with user to clarify their requirement and business flow, and then convert business flows into the event flows. Once events have been identified, repeat and reuse existing events from our event portal and extend their use to the new application. This diagram looks very complicated. We have thousands of events, and this diagram just shows about 10% of our events. We deploy a lot of products to provide better customer experience, and the UI design depending on different channels factors such as screen size, hardware, or device. For example, the web application provides rich information while the mobile client focuses on the user experience and interaction. The auto machines at the bench provide less information but a shortcut to allow customers to place bets quickly. Over 90% data of these products are the same. So decoupling the UI application and backend service is very important to us. In the past, our backend system needed to expose services to cater to different UI component or screen. Any requirement change affect both backend and UI, even if it is something just simple as adding or removing a single data field. Code tends to follow complex logic to handle any inconsistencies, such as when the same screen need to call multiple services. We also need to continue building new services based on the UI requirement. But now, with the EDA, we have the self-service platform that remove any dependency between channels and the backend system. Channel developer can now focus on the UI presentation. UI application just need to subscribe the event from the event mesh and display them. For example, when a customer pays a bet, On any channel, the channel will trigger a pacemaker event on the self-service platform. The backend service will then use the persistent queue to subscribe these events and processes. The successful back-pace action will trigger an auth update. The new auth update will be fed out to the different channel or self-service platform transparently. On our architecture, there is two layers on our architecture, event catalog and the service catalog. Service catalog allows the backend system to export the service for sharing, and UI application can reuse event from the event catalog. It is vital to ensure that best practices and compliance with the enterprise standard is followed during the design process. We have a technology taxonomy which is updated monthly when there are requests. It helps to ensure consistency and correct technology usage and simplify test support. Developer choose the technology and the corresponding product and version from the taxonomy and follow standards, guidelines, and best practices to develop their application. There are more than 70 pages on our taxonomy list, and it includes hundreds of the different types of the technologies and products. The naming standard ensures that event flow is understood across all domains within the organization. When developers need a new topic name for a new event, they must follow the naming standard, and our naming standard also defines the data flow process standard. The reference architecture defines architecture pattern to maintain application design consistency. Governments ensure that all designs are consistent and the agreed design is correctly implemented by the development team. We will run a health check on the SAT and production environment every half years, scan the event, analyze the log to find the application pattern if we find issue when we conduct this health check. For example, a topic name doesn't follow the naming standard or use an outdated API version of their application, we will raise a RCQ ticket for the developer to fix the issue. And finally, security compliance ensure that design meet the organization's security standard. This diagram shows how the system handles multiple event flows under EDA design. The key concept in an EDA design are async, isolate, and decoupled. Data-driven architecture, or DDA, is a very hot topic in this year, and the design is very similar to EDA. EDA focus to process, while DDA focus on the result. Both of them need an async real-time process, and the event match is a good technology to fulfill their requirement. Please note that publishing to the event match and not REST call process call will enable plug and play. The event process flow builds a relationship between different events to complete separate business operations. In traditional design, applications use a central control, but in EDA, applications use a distributed control. With the EDA design, we do not need to know how an event will be routed or what information will be needed by the subsequent steps. Event may pass through lots of the system during its lifetime, where it could mean different things to the different system or application. But the topic that present on the event message must retain constraint. From a topic naming perspective, the event's data component value should be solely based on the definition of the original proposed. of where the event comes from. A well-defined topic naming standard should include both mandatory and optional fields, with the mandatory field should not change throughout the lifetime of the event. The individual servers will not know when an event is coming from. Once it receives the event from a topic, it will process it, then publish the result to the corresponding topic based on the original incoming topic name. That means the component can be fixed to handle multiple event flows and doesn't need to hardcode anything on the application. In the development phase, developers focus on coding and reuse the existing event flow. They can either subscribe to an existing event or reuse servers that are available in the server's catalog. Sample code, which are classified into templates, are also provided as framework for reference. Application templates can be used for a base and extended and adapted for new developments and applications. This saves lots of development time while maintaining code standards. The implementation follows a low-code approach. Similar to the AWS, we have a very clear definition of the responsibility. The development team handles application-related logic and flow, while the event match team defines the reference architecture, standard, best practice, and guidelines, as well as review new event flow to make sure that they fulfill EDA requirements and management event match design, implementation, and support. We have multiple non-production environments to cater the different purposes. SAT, UAT, development, and SIT. We also have multiple projects running in parallel. So we need to have multiple instances for each of these environments. We set a production-like event match infrastructure to support all non-production environments. It allows us the flexibility to allocate the resources between different environments, which also allow developers to run HA and DRO tests on any environments instead of being limited to SAT. We can also route events between different environments, and developers can test application behavior based on different versions of the application. We use the Ready API to perform automatic unit tests, JMeter to generate time traffic, and CI/CD for auto deployments. Based on this infrastructure, we can cater for all non-production environment usage by just using one set of these tools. This can speed up our implementation and testing. The business benefit is close to the market, reducing the cost and risk. As mentioned before, events are used to complete separate business operations, but the value of an event is not limited to itself. Events on the operation data plan are linked together to complete a business function or an event process flow. The event match also allows us to link this event with different logic for other purposes. For example, enterprise data warehouse can subscribe to all events and use different methodology to analyze the data to provide better customer experience function, while the AI component can provide best suggestions based on the historical customer back records and auth information. End-to-end monitoring solution can provide the longitudinal statistics by monitoring the entry event and exit event. It also can link the event application log and network device log together to provide useful information for the real-time alert and troubleshooting. Using the event match, You can build any solution for any purpose. This function do not affect existing the event flow or application performance, but provide us with insights to focus on target goals and create better marketing campaign to have better customer engagement. The business benefit is designed by data or event. We have successfully built a smart digital platform in past few years. In the last year alone, more than 1.3 million customers used this platform with more than $1.2 billion worth of transactions processed. Constrained requests for enhancement and new functionality are unavailable to maintain a high level of customer engagement. Adopting EDA along with the Agile has helped the developer team cope with the steady flow of the new requests. With EDA, service components for business process are decoupled, with downstream services in the flow being associated by real-time event and handle asynchronous. Developer can focus on the individual portion of new function and performance, and easily incorporate change with CI/CD. For example, backend application developer can focus on the backend logic and database changes, while channel developers can focus on the UI presentation. Both of them can work confidently that the nearly implementation schema on the database will fit into the enhanced UI layers, because the event and event flow will guide the linkage and connect them seamlessly. Before I end my presentation, I would like to highlight one more thing. EDA is not just the architecture design or data flow change. It also requires a change of people's mindset. This is most difficult part. Senior management support is a must, and training is necessary. The training should be general, not depend on any individual project. At the Jockey Club, we have trained more than 300 colleagues to get EDA-related certification last year. The certificate college range from user, tester, developer, architect, PM, and management. If you have any questions, please feel free to contact us. We would like to share our experience with you. Thank you.